Next, we are going to be hearing from Ultinous, which offers video analysis services through a dedicated platform, UVAP, or Ultinous Video Analytics Platform. UVAP is a set of software services that can be composed and extended in a flexible way to build scalable AI-based video analysis capability and functionality. UVAP offers pre-configured elements and preset Dockers and is designed to work with Kafka, the widely used stream processing software. Users only pay for the set of features that they need, and as their business grows, they can adjust their licensing, easily adding new feature sets or extending the number of streams analysed. Join the live Q&A after the video using the link below.
Hi, I'm György Balogh, CEO of Ultinous. I've spent 25 years in AI research and the last 6 years in applying AI to video analytics products. Our company Ultinous is focusing on transforming the latest AI research results into security and safety video analytics products. Today I'm going to talk about how AI is transforming the video analytics industry. As an example, I will present our new product UAlarm and show some of the latest exciting research results that are likely to hit the market soon. We are experiencing an ongoing revolution in AI. It is called deep learning. As you can see on the graph, the error rate of image classification, where the machine has to tell apart 1,000 different object classes on photos, almost drops to half every year. This is an exponential trend. On this task, these models surpassed human accuracy around 2015 and still improving rapidly ever since. Deep learning models are trained on huge data sets. One of the largest datasets up to date consists of 500 million images. The computers can digest this magnitude of data in just days. This is orders of magnitude more than a human being can process over the entire lifetime simply because of physical and energy limitations. One of the most important properties of deep learning is that as we grow the size of training data, it becomes better and better. For example, in the game of Go, clever self-playing technique made it possible to generate a virtually unlimited number of training samples. As a result, deep learning in this game becomes superhuman, beating the best players by a huge margin. This property made it possible for deep learning to surpass human performance in many areas, like recognizing facing, playing Go, diagnosing diseases, and a lot more. But how is it used in video analytics? These models can detect persons, vehicle, object, as you can see it on the image. For example, deep learning is already much better than humans in face recognition. At the end of my presentation, I will show how it can be used to free text search videos with excellent results. Let's take a look at our latest product, UAlarm. Before we started the development of UAlarm, we looked at the video analytics market, especially video intrusion detection, and concluded that one of the main pain points is the high number of false alarms produced by cameras or video analytics solutions, pushing a significant part of the work to human operators. Majority of these systems today are relatively simple motion detection-based solutions, but these are not working in challenging weather conditions, are easily tricked by moving animals, plants, or even changing shadows. Modern AI solutions can decrease the false alarm rate significantly, but we also realized one of the main barriers for AI solutions is their high price. So we decided to develop a solution that uses the most accurate models, super easy to use, and still affordable. Hardware and way of deployment is key to cost efficiency and scalability. There are competing directions. AI cameras. A lot of manufacturers putting AI chips to the camera and run the deep learning there. Server-based solutions. Cloud-based solutions. In this case, you have to be aware of the bandwidth limitations to be able to stream the videos to the cloud. And edge devices. All these has advantages and drawbacks, and I believe they will coexist on the long run. We have chosen to optimize on edge devices because the solution is scalable, it's not limited by bandwidth constraints, and can be added to existing camera infrastructures. We have around 1 billion surveillance cameras worldwide today. UAlarm runs on NVIDIA edge devices and servers. The NVIDIA Jetson family is optimized for video analytics. These boxes has no moving parts and don't require server rooms. They can be deployed close to the camera system. The Jetson NX box can run temporal streams. This translates to approximately $100 per stream hardware cost. UAlarm can be deployed to any existing camera infrastructure, adding state-of-the-art deep learning analytics to existing cameras. UAlarm uses deep learning models that can classify persons without any configuration. This makes UAlarm a super easy to use plug-and-play video on-tick device, which I will demonstrate shortly. Currently, UAlarm can detect intrusion and crowd, other object categories next on the roadmap. UAlarm has great flexibility to push alarm to different systems. It can send alarms via generic HTTP post message to virtually any third-party system. It has connector to Milestone X-Protect and can send alarm via email. Let me give you a quick tour how easy to set up UAlarm. Once we unpack the box, we need to power it on, connect it to the network. We need to run the discovery tool on a Windows machine to find out its IP address. Once we have the IP address, we can log into its web interface. Let's set the camera. We will use the RTSP URL to identify the stream. Then, after a couple of seconds, we can see the feed from the camera. As a next step, let's add an intrusion detection alarm. Here we can set the region of interest. Narrowing down the search area further increases the accuracy, focusing all the hardware resources to the target area. There are many ways to push alarms to third-party systems. UAlarm can send HTTP post message, email, and have an extensible connector architecture to support different VMS systems. Here we are using the Milestone connector to feed the alerts to Milestone X-Protect. That's it, UAlarm is configured. Let's test it. As you can see, the alarm arrived to the VMS system. This is in our office, but let's see how it works on the field. Our partner Securify in Sweden has done an extensive field testing using a combination of radar, PTZ camera and UAlarm. This one system can cover a 400-meter radius circle and detect persons with high accuracy at day and night. How it works? The radar picks up any moving object, by itself reporting over 100 false alarms a day. This is unacceptable, but adding a PTZ camera and UAlarm, this can be decreased to virtually zero. The PTZ camera zooms in to every target and provides good quality observations for UAlarm. The deep learning models of UAlarm classify the object with super high accuracy. The video analytics works in the near infrarange as well, using directed infra technology. The effective range of the system can be as long as 400 meters, even at night. What you can see on this image are real intrusion caught at night. The range of this detection is 250 meters. On these other images, you can see some other examples demonstrating the range and night vision capabilities of UAlarm. For example, on the top right corner, you can see a detection which could be challenging even for a human to detect. Accuracy of deep learning models have not saturated yet. Close to human-level visual perception seems to be achievable in the coming years. Also, new types of models are emerging, opening up new application possibilities. At Ultinous, we are closely monitoring both the market and the progress in research and technology and build our roadmap based on these. As a next step, UAlarm will get object detection and counting over 20 different object classes and sophisticated object attributes. For example, alert can be defined if a person enters a factory area without safety helmet. Let me give you another exciting example. Recently, Elon Musk's OpenAI have released a very powerful model called CLIP. This model has been trained on 400 million image-text pairs, and probably multi-million dollars has been burned just for the machine hours to train this model. We have developed a video indexing and free text search engine and a demo application using this model. Let me show you a few examples to demonstrate how it is capable to understand sophisticated and abstract queries. You can see the demo application here. First, let's select the movie Baraka, which contains a wide variety of sequences covering nature and human society. On the top right corner, we can type the free text query in English. The engine instantly returns the top 5 matching frames from the full movie. Clicking on the frame seeks the video player to the frame position. So let's give it a try. Let's type A monkey is sitting in the hot water. Then you can see the result. This is a complex query involving detecting objects, actions, and other attributes. But let's see some more. Let's type, a woman is washing her hair. Or, a family on motorbike. Let's type some more abstract things. A solar eclipse. Okay, let's pick another movie, Home Alone. And let's type an old man hugging a girl. Let's be even more specific, involving multiple parallel actions. An old man hugging a girl and waving with his hand. Nice. In these examples, the videos were indexed at the frame level. If we index the videos at object level, complex scenes can be queried. Let's see. This 1-hour video has been shot in the streets of New York. Okay, first let's look at some cars. Let's type purple car. Okay, be more specific. Let's type purple van. Nice. Let's type white Jeep. Or a red Porsche. Let's look for a FedEx car. Or a bus with no service. Notice the sign on the bus, which the model read and understood correctly. Let's type a woman with checkered dress. Okay, let's try some actions as well. A woman is waiting. Or a blonde girl entering a door. I think these models are amazing. So stay tuned, free text search is coming to Security Video Analytics soon. We will be exhibiting on IFSEC in July, so please visit our booth if you are interested in more details. Thank you for your attention, and I'm happy to answer questions.
Welcome back to our Tech Talks today, where I'm delighted to be joined by Mickey and Janos from Ultinous, who are going to be here to answer any of your questions that you may have had from watching their presentation just now. But just to ease the transition of people into the Q&A and to set the scene for anyone who may not have been able to watch the presentation or maybe joined in a little bit late. Mickey, I'll come to you first of all. In a nutshell, tell us about Ultinous and about what you're very keen to share with our audience here today.
Thank you very mumuch, David. Hi, everybody. Well, there are a lot of things that we'd like to share, actually, but since our time is limited. So first of all, Ultinous was founded in 2015, so we're not really a startup, but been in the development scene for quite some time. We're focusing on AI-based video analytics, and and have had a few products on the market already. But as of February this year, we launched our first end-to-end solution, the U-Alarm, which is an edge-based intrusion detection and crowd management solution, really specifically focusing on low false alert rates. That's probably our strongest key point. It's very scalable and easy to use. So that would probably be a little short introduction in a nutshell. And I'm not going to call Austin Powers.
Thank you very much indeed. And you know, I was taking a look through the presentation, and wow, I mean, the power that however you address it, artificial intelligence, deep learning, machine learning, for example, that the power that that's able to bring, the capabilities that it's able to bring are really quite staggering. So what I'd like to kick off with really is just talk to me about the potential benefits that machine learning, but we've got a question here, the difference between deep learning and machine learning. So let's try and wrap that up into it. What does AI as the umbrella term bring to your customers?
Okay, that's a really good question. First things first, these are quite overlapping terms. So sometimes when we are talking about deep learning, we refer to machine learning and vice versa. However, technically, machine learning usually uses GPU instead of CPU when it's training. The amount of the training data is quite different, and the length of the training time. So it's, let's say that this is an artificial intelligence training method, specific one among the largest term, which is machine learning. Mm-hmm. And about the capabilities, as Yuri, our CEO, mentioned in his presentation and his video, the deep learning is able to beat human beings' observation capabilities because of the amount of the training data, and because human workforce is not as endurable when, for example, coming to security surveillance. So, for example, an operator's attention tremendously drops down in a couple of minutes when an artificial intelligence solution can still watch the whole perimeter.
Indeed, and looking again at some of the examples that you shared, that your CEO shared in the presentation there were some that particularly at distance and in low light, where I was looking at the screen going, I can't see anything moving at all, yet your system was able to identify some kind of movement, intrusion detection, whatever there. So, you know, do you have any metrics in terms of the detection range and in terms of the low light capabilities? Is there any way of quantifying that side of the benefit over the normal human recognition?
Yeah, technically we can detect human beings from 30 pixels height. And this means that the quality of the camera will determine the detection range. But I can give you a good example. For example, a full HD camera with 40 degrees of field of view is capable to detect with U-alarm people from 84-85 meters. And if we are talking about 4K resolution, then it can be the double.
Okay, thank you very much indeed, Janos. Questions, please do keep your questions coming in. There's some on here. We've already addressed the difference between machine learning and deep learning. We've got a question here. Does U-alarm work with any surveillance camera? Are there any minimum requirements for the device that it's being used with?
As long as it is capable to provide RTSP stream, there is no other limitation.
RTSP, very, very standard protocol for, okay, thank you very much indeed. Another question here. I've never seen any automated solutions which work with P2Z cameras. How does it work?
The PTZ cameras are quite hard for most of the solutions because it uses motion detection. And while a PTZ camera zooms in and pans and moves other way, then from the solutions perspective, everything is moving. So it spoils the detection capabilities. However, our solution is able to analyze frame by frame in a good frame rate, and this is sufficient enough to detect people, especially if the camera's zoom capabilities is as good as for the Securify use case use. So we can detect people from 400 meters if the zoom capabilities and the infrared capabilities are that good on that particular camera.
Wow, impressive stuff. Thank you very much indeed, János. Another question's coming here. We've got 3 thumbs up. If there's a question that's being asked that is one that you would have asked too, then give it a thumbs up here in the Q&A. And this one's got 3. Since the U-alarm is connected to the internet, how is it protected against online threats? As we know, anything that's connected to the internet, any Internet of Things devices are potential targets for those who would do our systems and other people's systems harm. So what are you doing to ensure that your systems that are internet connected are as robust as they could possibly be?
Actually, U-alarm does not require any kind of internet connection. So it can work in your local network, and this ensures that no recordings goes out from your site. So you own and you have the full control over the data and the video record provided.
Really interesting stuff. Thank you very much indeed. Another question that is being asked because of the times in which we're in is about accuracy considerations, challenges faced with the COVID measures, face masks, for example, that many people are wearing that obscure large parts of their faces. Does that present any challenges for your technologies?
No, because the network is trained on full body detections, so it does not require any visible faces or a kind. You can wear bandanas, helmets, or anything. As long as your body shape is human, then you will be detected.
Super. Thank you very much indeed. We've just got a couple of minutes left with Mickey and János, so please do keep any final questions coming in before we wrap up. A question that I've got in terms of the practicalities of the installation. Does your system work with multiple camera feeds? Just the one? How does it scale?
We are currently supporting 2 versions of the NVIDIA Jetson families. The first one is the NVIDIA TX2, and the next one is the NVIDIA NX. And we are capable, based on the machine, to support 4 cameras or 10 cameras at a time for intrusion detection. And the scalability is quite simple because it just scales up with the number of devices.
Okay, thank you very much indeed. We've got a question that just snuck in here at the end. We're obviously talking about the P2Z, about the challenges or opportunities of working with that, about the range. There's a question that's coming with regards to cameras. Does it work with thermal cameras?
Tricky question. U-alarm does not process the thermal view of the cameras. However, on most of the sites where there are thermal cameras, there are classic cameras as well, just in order to verify the existence of a human being at that area. And this is where we come into the picture. So a thermal camera can be quite good, but it can be triggered by any heat sources. And this is why usually there are some classic cameras there. And what you all aware of, the thermal cameras are much more expensive than classic cameras.
Indeed, János, thank you very much indeed. Final question for now, because we are out of time pretty much. Mickey, to you, is just tell us about, if people want to find out more, they want to try, they want to buy your systems, tell us about how they can reach out to you and start doing that.
Well, finally, I get to say something as well. A lot of techie questions here. So basically, we have a market organization, and we have integrators, distributors in many European countries. So the best thing to do is to have a look at our website, ultinous.com. And from there on, you can just easily go to our product site or just request a demo, or for somebody to get in touch with you. So basically, it's as simple as that.
Super stuff. Well, listen, thank you very much indeed for answering the questions that our audience have been throwing at you both today. Really good stuff. Thank you for taking time out, and hope to speak to you again soon. Speaking of which, a quick reminder that we'll be hosting many more of these tech talks at Connect 2021, which takes place online from the 1st of June to the 30th of June, and also as effective as these online events can be, and goodness knows we've been experiencing a lot of them over the last 12, 13 months or so, I am definitely itching to getting back to meeting face to face, which is why we're very, very excited indeed to announce that IFSEC International and FIREX International will be taking place in actual person from the 12th to the 14th of July at our old stomping ground, the Excel Centre in London. Find out more and secure your place at both of these by heading to the IFSEC International or FIREX International websites, like on the screen right now. And yeah, book your place and hope to see you there. But for now, take care. Hope to see you at another one of our Tech Talk sessions later on. Again, Mickey, Janos, cheers.
Thank you. See you at IFSEC in July.
Thank you. See you later.